Hello, myself Dr. Vijay Chandra Jedla welcomes you to today's session on cloud computing. As part of cloud computing series, today I am going to discuss related to the networking concept. Myself Dr. Vijay Chandra Jedla, Associate Professor, Department of Computer Science and Artificial Intelligence, School of Computer Science and Artificial Intelligence, SR University. Today, as part of Cloud Computing series, Unit 2, that is Core Enabling Technologies, today I am going to concentrate on networking, where we are going to see Virtual Private Cloud of AWS. Let's check the networks. What do you mean by a network? Previously, there was a single computer that is considered as a stand-alone computer. This particular computer, if it is connected to another computer to share the resources such as printers and scanners. So, printers and scanners are the resources where both computers or more than two computers are going to share, then it comes under the network. There are major types of topologies of the network: ring topology, star topology, bus topology, and mesh topology. These are the way how these particular networks are connected is considered as a topology. And there are three different types of networks, that is LAN, local area network; MAN, metropolitan area network; WAN, wide area network. Now, in a particular network, we are going to see a router, subnets. A router will be connected through the subnets to two different networks. If you have to connect two different networks, then you have to connect to the router and to the subnet. Next comes to a router. What do you mean by a router? A router is a networking device that allows you to transfer the data packets within the network. So here it is a networking device which forwards the data packets between the two different networks. So if two different networks are there, we are using the router to connect these two different networks, and we are going to use the subnet to connect this particular routers. So what do you mean by a subnet? A subnet is a shortly it is called subnet, and it is means subnetwork is a simple smaller logical division of an IP address, and that helps to organization to organize the efficient route traffic with larger network. Within the larger network, this route traffic will be identified and automatically will be connected with the help of the IP network. So a subnet, short for subnetwork, is a logical division of the IP address for the connection of the network with the efficient route traffic within the larger networks. Then comes to the networks. What do you mean by network? Network is a collection of interconnected devices such as computers, servers, routers, switches, or IoT devices that can communicate among each other. That means the resources, the shared resources of the data, or for the communication of the each other, then it is considered as a router network. So in network which we discussed till now, we discussed about the router, we discussed about subnet, and we go through the term known as the IP address. So what do you mean by IP address? IP address is an internet protocol address which is of 4 divisions. Okay, that's why it's called as IP4. There are two different types of IP addresses. One is IP4 and another is IP6. So let's understand with the IP4 right now. 192.168.1.1 is an example of the IP address. Then 192, which converts into the binary, then 0, then 210, then all zeros. This is an IP address where there are two types of IPs. One is the public IP address, another is the private IP address. Private IP address means it will communicate within the network, whereas the public IP address, it will communicate through internet or to wide area networks. So, and it will be available for all the people who are with the IP address. So the public IP addresses reachable from the internet, whereas private IP address within the internal networks. So these are the two differences related to the public IP and the private IP. There are majorly two types of IP addresses. One is the public IP, another is the private IP. Next comes to the CIDR notation, where 192.168.0.0 by 24, which defines as an IP address. Let's see here, there are two different types of IP addresses, that is IPv4, which is of 32-bit. Example is 192.0.2.0. Then next comes to the IP6 address, which is of example of 128-bit address, that is 2600.1F18. Like that, for every 4 consecutive unique numbers there will be colon, like that 1, 2, 3, 4, 5, 6. So around this is all about the 128 IP address, 128 bit IP address. See example 1200 colon 1F18 colon 22BA colon 8C00 colon 2A86 colon A05E colon A5BA colon 00FF. So this is all about the IPv6, and previously we had is the IPv4, where 32-bit address 192.0.2.0 is used. Next comes to the class inter-domain routing. So based on the classes it will be routed. So network identifier with the fix, host identifier, then /24. So every up to 24 tells you how many bits are fixed. So here 192.0.2 is fixed. When it has to connect to the same local area network, here the host identifier will come to the 1, and this is the address of the router configuration 192.0.2.0. Then when we are connecting this to a computer, then that particular computer IP address will be 192.0.2.1. like that we can give up to 254 we can give, or 255 we can give the connections to one particular specific router address. So this is all about the class inter-domain routing, CIDR. Then comes to the layers of the computer network. The major layers are of OSI model, which is the standard model. The standard model is the open system interconnection model, that is OSI model. So this particular layer, this OSI model is divided into 7 layers. The first layer is the application layer, presentation layer, network session layer, transport layer, network layer, data link layer, and physical layer. The numbering which we starts with the 1, that is the physical layer, which transmits and reception of raw data between raw data bit stream on the physical medium. Based on the physical medium, this raw data will be transmitted in the form of the bit stream. Then comes to the second layer, that is the data link layer, where this particular data link layer transfers the data in the same local area network through hubs and switched. So this will identify the MAC address, that means it will identify the system at this particular data link layer. Next comes the network layer, which is the third layer, and it identifies the IP address. So internet protocols will be identified through this network layer, where routing and packet transferring of the routers or the major concept of the IP address. Then comes to the transport, that is 4, which provides the protocols to support the host to find the communication. So this communication will be identified within the network by using TCP or UDP. Then comes to the next layer, which is known as the session layer, where it enables you only exchange of data, that is network BIOS, that is RPC. Then comes to the presentation layer, which is of 6, where it ensures the application layer that can read the data encryption. So data encryption will be done through the presentation layer. The encryption and decryption are the two processes for the security of the data, where the data is converted into the ciphertext. The plain text will be converted into the ciphertext at the decryption, and at the encryption this ciphertext will be converted to the plain text. So presentation layer, it ensures the application layer and support it for the sake of the encryption. Next comes to the application layer. The application layer means for an application to access and compute the network. So here the HTTPS, FTP, DHCR and LDAP are the different protocol addresses which are related to the application layer. Next comes to the subnetting. Subnetting is networking fundamentals is related to the subnetting. So subnetting deals with the divides a large network into smaller manageable pieces. So here the major network is divided into subnet, and these subnets are connected through the routers. So here important for isolating workloads, that is front end and versus back end servers, these subnetworks are used. Example 10.0.0/16 is a subnet for 10.0.1.0 and 10.0.2.0 up by 24. So this is all about the subnetting. Then comes to the after subnetting, routing. Routing is part of the network fundamentals. The traffic will be moved from one place to another through the routing concept. So the routing moves the traffic from one network to another. Routing tables define the rules to traffic detection. The example related to the routing will be a traffic from private subnet routes to NAT, which gives the gateway to access the network. So this is all about the concept of routing. Then after routing, the next concept we are going to discuss is the domain name service, DNS. These are the basic principles or basics of the networking fundamentals which we are covering right now. Then we will discuss related how these networking fundamentals are related to the Amazon Web Services, that is AWS. Now about the DNS. DNS means domain name system, which resolves domain names to IP addresses, crucial for making applications access via custom names, that is api.myapp.com. So here the client and the DNS server, it will be connected with the common IP address. So the IP address in the form of which you will type in the URL in the form of URL or in the form of numbers, that is 92.184.216.34. Then comes to the firewalls. Firewalls are the major concepts related to the security, and firewalls are for the sake of the protection from the intruders. Okay, the firewalls and the security rules. The security groups of AWS are used for the sake of the security in AWS, whereas in Azure, network security groups will be available to filter the traffic by portal and IP. Then comes to the types of firewalls. There are majorly two types of firewalls are available. One is stateful firewall, another is the stateless firewalls. So stateful firewall track connection state, whereas stateless evaluates each packet individually. It will identify the packets and it will evaluate the each packet. Next comes to the NAT. NAT means network access translation, which allows the private resources to initiate the internet connections without exposing them. So here using in NAT Gateway in AWS and same in the Azure or GCP. So the internet network will evaluate with the NAT through the public network, public IP addresses, and the local network will connect with the other subnetworks, and then it will be connected through the resources. Then comes to the next concept related to the load balancing. So here in the network there is a option of load balancing. If one server is getting high load, then it will be shifted to the another server when we are working with the multiple servers. In AWS works with multiple servers, data centers all over the world. So here the concept of load balancing plays a major role. For the AWS there is an AWS elastic load balancer. So the basic concept as part of the network fundamental related to the load balancing we are going to discuss here. It distributes incoming traffic across multiple servers. The types are layer 4 where TCP by UDP, then layer 5 where it is HTTP by HTTPS with application load balancer. Then comes to the static load balancer and the dynamic load balancer. There are two different load balancers. As you all know, there are two different types of the websites, where one is the static website, another is the dynamic website. Static website, it will not change constantly. Once it is uploaded or deployed, it will be constant with that particular data on the internet, whereas the dynamic website will change dynamically, that means continuously it will change. So here the static website, the static load balancing, the web application will be connected to the web servers through the load balancer, where it is an hardware load balancing with the static load balancing algorithm rules. So based on the static load balancing algorithm rules, this particular load balancing will work, whereas the dynamic load balancing, it is a software load balancing. Continuously it will shift, it will check every time and it will change the loads among the server. So that's why it is considered as the dynamic load balancer. Next comes to the VPN, virtual private network. So a particular organization want its own network, then it is considered as a virtual private network, where in AWS it will be provided by VPC, virtual private cloud. So virtual private network is meant for the security. It securely connects on premises data centers to cloud VPC, and it encrypts the data transfer over the public internet. So here the user is there, internet is there, it will be connected in is not through the as it is not connected through the in encryption. Without VPN, if it is directly connected, there won't be any type of encryption, there won't be any type of security to connect with that only for that particular organization. That means here the address will be if it is not connecting with the VPN, the address will be of the public. When it is connecting with the VPN, the address will be of the private, and based on this particular IP address only a user can connect to the through internet to the host, where the VPN server will act related to the verification of either a public IP address or a private IP address. Then comes to the VPC, which is considered as the virtual private cloud. So VNet is used for the Azure. You are in a isolated network within the cloud provider, then this particular VPN or VPC will be used. You can identify the IP ranges, subnets, route tables and gateways, in particular VPC, Virtual Private Cloud. Networks fundamentals, that is Amazon Virtual Private Cloud, which ensures you to provide a logically updated concept of virtual private cloud, where the logically isolated section of the AWS cloud network, as part of networking fundamentals, Amazon Virtual Private Cloud, which enables you to provide a provision of a logically isolated section of the AWS cloud, where you can launch AWS resources in a virtual network that you define. So here in Amazon VPC, there will be a provision of logically isolated section which will launch the AWS resources in virtual network. It gives control over your virtual networking resources, which includes selection of IP address range, creation of subnets, configuration of route tables and network gateways. It enables you to customize the network configuration for your virtual private cloud. It also enables you to use multiple layer of security. Here networking fundamentals is related to Amazon Virtual Private Cloud and subnets. Here you can observe virtual private cloud in subnets or in two different zones, zone 1 and zone 2. This particular subnet is in zone 1 and this particular subnet is in zone 2, and this total comes under virtual private cloud. And there is an availability zone, that is availability zone 1 and availability zone 2, two different availability zones in one particular region. They are working in the AWS cloud. So VPC, Virtual Private Cloud, logically isolated from other VPCs, that is dedicated to the AWS account before a single region, and can span to the multiple regions, multiple zones. So here it will work in a single region and it will connect to the multiple zones. Subnets. Next comes to the concept of subnets. Here the range of IP addresses that will divide the VPC, Virtual Private Cloud, belonging to a single availability zone, and it is classified into two different types. One is the public, another is the private. Whereas the private virtual private network, you cannot send it through the network, it should have the internal network, whereas public, through internet, it can be accommodated all over the world. Next comes to the VPC IP addressing, how the IP address will be there for the VPC. Virtual Private Cloud networking, IP addressing. So here when you are creating a virtual private cloud, you assign it to an IPv4 CIDR block, range of IPv4 address. Based on the IPv4 address related to the CIDR block, it will work. You cannot change the address range after you create the virtual private cloud. You cannot change this particular address range. The largest IPv4 CIDR block size is /16. Then comes to the smallest IPv4 CIDR size is /28. So IPv6 is also supported with a different block size limit, where the CIDR blocks of subnet can overlap. So here VPC is virtual private cloud, whereas x.x.x by 16 or 65,536 addresses are of max to x.x.x by 28 or 16 addresses with min. Then comes to the next concept known as the reserved IP addresses. There are some reserved IP addresses, that is 10.0.0.0 for the network address, 10.0.0.1 for the internal communication, 10.0.0.2 for domain name system resolution DNS, 10.0.0.3 for the future use, 10.0.255 for network broadcast address. So here 10.0.0.0 will be generally connected to the root, and up to 3 or 5 they will keep for the reserve, and 10.0.6 onwards, 10.0.244 you can 254 you can give to the different systems in a particular local area network. So here a virtual private cloud IPv4 CIDR block of 10.0.0 by 16 has 65,536 local IP addresses, that is in combination of them. The VPC has 4 equal size subnets. Only 251 IP addresses are available to use by each subnet mask. So this is all about the reserved IP addresses, where VPC is 10.0.0/16, then subnet 1, subnet 2, subnet 3 and subnet 4. 4 subnets can be connected with the VPC here. Then comes to the different types of the public IP address types. There are two majorly public IP address types. One is the public IPv4 address, another is the elastic IP address. So here manually assigned through a elastic IP address, it is considered as public IPv4 address, then associated with an AWS account that is related to the elastic IP address. Next comes to the automatically assigned through the auto assign public IP address setting at the subnet level. At the subnet level you are going to set with the public IPv4 address. Then comes to the elastic IP address, which is related to the allocated remapped any time of the address. It's considered as an elastic IP address. Then comes to address cost may apply for this particular elastic IP address. So here till now we discussed related to the network interfaces. Now we are discussing related to the elastic network interface. An elastic network interface is a virtual network interface where you can attach an instance, you can detach an instance, and you can attach another instance and redirect the network traffic. These are the major advantages comparing to the other type of the network interfaces. Elastic network interface has a provision of virtual network interface where you can attach the interface, you can detach the interface, and this attachment another interface will be redirected to the network. So here its attributes follow when it reacted to new instances. Wherever you have the new instances, this attributes will follow it. Each instance in your VPC virtual private cloud has default network interfaces that is assigned to a private IP address from the IPv4 address range of your particular VPC virtual private cloud. Next comes to the networks route tables and routes. Here the network route tables VPC CIDR block, which is related to the main default, and another is the route table. This destination is 10.0.0.0 by 16, where it is a local target. So here the root address contains a set of rules which are considered as a routes that can configure at least network traffic from your subnet. So here the route table contains a set of routes that will configure to direct the network traffic in a particular subnet. Each route specifies the destination of the target, and by default each route table contains local route for the communication within the virtual private cloud, and each root related subnet must be associated with the root table. So this is all about the root tables and the roots. The next concept is related to the virtual private cloud. So here the most important concept related to the AWS is virtual private cloud. In networking, AWS networking maximum depends upon the virtual private cloud, that is VPC. A VPC is a logically isolated section of the AWS cloud. VPC comes under the core technologies of the AWS cloud. A VPC belongs to one region and requires CIDR block. So here the VPC is divided into subparts. Those are considered as the subnets. A subnet belonging to a one availability zone requires one CIDR block. And next comes to the route tables, which controls the traffic for the particular subnet. Then comes to the route tables have the built-in local route. Here you can see the additional routes to the particular table, and the local route cannot be deleted. These are the major concepts related to the AWS virtual private cloud. Next comes to the internet gateway. Please observe the diagram where it enables you to provision a logically isolated section. It enables you to provision a logically isolated section of the AWS cloud. So here where this will AWS resources will launch on a virtual network. This virtual network is considered through the virtual private cloud. Here we can give you the control over your virtual network resources. What are these particular virtual network resources, or which includes or selection of IP address range. You are going to select the IP address, then creation of subnets, then configuration of route tables and network gateways. These are the three different concepts related to it, that is selection of IP address range, creation of subnets, configuration of route tables and network gateways. Next comes to it enables you to customize the network configuration of your virtual private cloud. It will customize the network configuration that is related to the virtual private cloud. Next, it also enables you to multi-layers of the security. It enables you to customize the network configuration to the virtual private cloud. The virtual private cloud is legally associated from other virtual private clouds which are dedicated to the AWS account. So here single AWS region can span to the multiple zones. So here you have to understand that the single network region can be connected to the multiple zones, and subnets related to the subnet range of IP address is to divide the virtual private cloud, and it belongs to single availability zone. This single availability zone is classified into two different types. One is the public and another is the private. So this is all about the virtual private cloud related to the internet gateway. You can understand here this is the route table and the internet gateway is here. Through internet we are connecting through internet gateway and route table, and here there is a public subnet, another is the private subnet. These two types of the subnets are connected to the virtual private cloud in the same availability zone, and the availability zones are there in the region, and this total regions are there in the AWS cloud. This is the total architecture of networks related to the internet gateway. After this, the network address translation gateway. So here now we are going to discuss related to the networks, that is related to the network address translation gateway. You can see this is AWS cloud, and the AWS cloud in the region there is an availability zone. In this particular availability zone, two types of the subnets are available. One is the public subnet, another is the private subnet, and public subnet is connected with the network gateway, and this two and the private subnet is connected to an instance, and these two connected to the public root tables and private root tables. So public root tables are connected to the public root table and private root table. Then these are connected to the internet gateway, and through internet gateway it is going to be communicated. So here there are two sub root tables. One is the public subnet root table, another is the private subnet to root table. The destination is 10.0.0 by 16, which is of local. Then comes to the 10.0.0 by 0. Then the same thing with the private network, private root table. So here we are discussing with related to the Amazon Internet Gateway, which is horizontally scaled and redundant to the high level availability virtual private cloud components. So here the key functions of this are enabling the internet access, two-way communication, root table integration, NAT for network address translator for the IPv6 within the VPC, and it will be translated to the public IPs for the internet communication. So how they are connected? They are connected to the majorly three different components. One is the root tables, and another is the subnet, public subnets. So by this we discussed related to the network address translation, that is NAT gateway. Networking fundamentals, ports, fundamental ports and protocols. Let me discuss related to the different fundamental ports and protocols. The first one is FTP, which is File Transfer Protocol. This particular protocol has port of 20 data and 21 control, and its function is used for transferring the files from client to server. The name itself saying File Transfer Protocol. So it is used, the function of this FTP protocol is it will transfer the files from client to the server. After FTP protocol, the next protocol which we are going to discuss is SSH, which is considered as secured shell. The port is 22 and it provides a secure channel over unsecured network using a strong encryption. So SSH is a secured shell which is meant for the security, and it will provide a secure channel over an unsecured network by using strong encryption, commonly used for remote command line login, remote command. Next comes to the concept of telnet. Telnet is meant for the telecommunication network where the port is 23. The function of this particular telnet is, that is telecommunication network, is it provides a simple unencrypted text based communication channel for remote access to servers and network devices. It's going to give the communication for the remote access for the servers as well as network devices. It is highly suspended by SSH due to security concerns. Next comes to the SMTP, that is simple mail transfer protocol. That port is 25, that is sending mails. 465, which is SMTS, which is the secure. 587 is the submission point, where this particular function used for sending email messages between the email server, that is mail server, from client email to the mail server. So here this is for sending the mails. This protocol is meant for sending the mails. This is the transfer protocol, SMTP, simple text transfer protocol, which is meant to send the mails towards the server, and this protocol sends the mails from email messages from mail servers to client servers, that means from client servers to the mail server. Then comes to the DNS, domain name system. Domain name system is a port of 53 which functions the translates human reliable domain. The domain is given in the URL. That means actually through IP address a website can be launched, but with the IP address no one can understand the name of the website. So for masking it, we need a domain address. So we need a domain protocol for the sake of DN, that is considered as the DNS, that is domain name system, where you will get an URL which is to activate the website instead of numerical IP address. Instead of 192.168.4.9 like that, a number you can give www.sru.edu.in. So that is the domain name service, DNS. Then comes to the HTTP, Hypertext Transfer Protocol, which is the foundation of data communication for World Wide Web, which is used for the retrieving of web pages from the web servers. This HTTP protocol is directly connected to the web servers, and it helps us to retrieve the web pages from this particular web server. Then comes to the Kerberos, which is the network authentication protocol, which works for the basics of tickets. It will raise the tickets that allows the node to communication over the network. It will provide the secure network to provide their identity to one another in a secure number. This comes under the Kerberos. Next comes to the POP2, which is the post office protocol, which is considered as post office protocol version 2, POP2. This is the older version of POP for retrieving the email from the mail servers. It is largely used. Then comes to the POP3, that is another version. Then comes to NTP, network time protocol, which is used to check the synchronization of the clocks of the computer system over the network. Next comes to the NetBIOS NS, that is NetBIOS name service. It is used to identify the NetBIOS name registration and its resolution. Next comes to the NetBIOS BGM, which is considered as NetBIOS diagram service, which is considered as a function which is used for connectionless network BIOS. Then comes to the IMAP, which is considered as Internet Managed Access Protocol. This protocol is used by the email clients to retrieve the email from the mail server. The messages are provided to remain on the particular server, which allows to access from multiple devices. Then comes to SNMP, which is considered as a simple network management protocol. The ports are of 161. It is used for managing and monitoring the network devices. Next comes to IMAPv3, that is Internet Message Access Protocol version 3. It is the older version of IMAP. So it specifically refers to the integration with the largely open secured protocols. Next comes to the HTTPS, Hypertext Transfer Protocol, for the sake of security. HTTPS is a secure version of HTTP, which is SSL by TLS encryption to secure the communication between the internet and the web browser and the website. Then comes to the Kerberos DS, which is meant for the sake of the directory service. So these all are the different protocols which we discussed in the as part of network fundamentals, that is about the protocols and the ports. So next is the socket, that is related to the socket secure, which which functions for the sake of the network proxy protocols that will allow the server application to transferring them by using of the services of a network proxy server. So these are the different types. Then comes to the network file system and other protocols, MySQL, where this is a default port, the port is 3306, and this is meant for MySQL relational database system used for the client application to the server. So these are the different types of the protocols which we discussed here. Then after this, the next concept is related to the TCP and UDP. Network fundamentals related to the TCP versus UDP communication. TCP means transmission control protocol and UDP means user datagram protocol. These are the two most commonly used and most fundamental protocols in internet for the sake of the network. Then these protocols, that means internet protocol suites will run on the operating system of the transport layer. So already we discussed about the different layers of OSI model. In that particular OSI model, these protocols will run on the transport layer. The internet protocol suite will work on the operating at transport layer, and they will have the applications between over the network, but they or even have the different approaches, making them suitable for different types of applications. Then comes to TCP, transmission control protocol, then which is connection oriented, that is before you have the data to send, TCP is established as a dedicated connection between the sender as well as the user. Then comes to there are three-way handshake, that is SYN is ACK and SYN acknowledgement and synchronization. The other characteristics of the protocols are reliability. Then comes to the acknowledgements, retransmission, error checking and flow control, cognation control, order by delivery. These are the different concepts related to the TCP as well as UDP. So here as part of network fundamentals, TCP versus UDP communication. TCP where it will be communicated between the client and server through synchronization back and acknowledge. Those are the communication way of communication. Then comes to the UDP, request and response related communication. So this is all about the communication. Then comes to the latency, bandwidth and throughput. So these are the major concepts related to the fundamentals of networking. So it is important when you are designing the high performance scaling systems to take care about the latency, throughput and the bandwidth. How for bandwidth? Based on the bandwidth only the network communication will be done. Latency will give you the response time, and throughput, the flow of network flow will be considered through the throughput. So it all influences the choice between the multi-region versus single region deployments. So these all related to the latency, bandwidth and throughput, which are interrelated for the network fundamentals. Then in this particular bandwidth, what do you mean by bandwidth? It is the maximum capacity of the network that can be handles the data. So it is for example the diameter of a particular pipe is considered as a bandwidth. So here for the sake of the network data packets flow, the bandwidth plays a major role. That means how far the bandwidth is high, the network speed will be very high. Throughput, this is the efficient amount of data that passes through this given line is considered as a throughput. So latency is how the test will be done, related how fast the data will reach the server, that is related to the latency. So these three are the major principles related to the network fundamentals. Now we are going to see virtual private cloud peering, that means connection between two different VPCs, that is considered as the peer communication. So here you can connect the virtual private cloud on your own AWS account between AWS accounts or between the AWS regions, but there are some restrictions that are IP addresses cannot be overlap, there is no chance of overlapping of IP addresses. Then transmission peering is supported. Then you can only have the one pricing resource between this two VPCs, that means they should be of same pricing source, that means same level, then only they can be connected. So here the route table of VPC A and route table of VPC B, this is to show the communication between them. Then comes to the network AWS site to site virtual private network. So in AWS cloud region availability zone, two different in VPC two different types of networks are available. One is the public network, another is the private network, and these two are connected to the route table, and this private network is connected to the route table, and through virtual gateway it is connected to the site to VPN, and from there it is went to the customer gateway, and from that it went to the corporate data center. So this is all about the networks AWS site to site VPN. Then comes to the IP address types. So here, as previously, AWS cloud, the region there are two in the availability zone, there are two types of subnets. One is the public and another is the private. The private went to the route table through virtual gateway, and through the virtual LAN it is connected to the AWS Connect and customer gateway. This AWS Connect is supported with the internet, and it went to the corporate data center. So these all are the different types. Finally, the network VPC endpoints. What are the endpoints? When you are connecting with the DNS host names or endpoints will specify the DNS host name. There are two types of endpoints. One is the interface endpoint, which is powered by AWS Private Link, and another is the gateway endpoints, that is AWS S3 and Amazon DynamoDB. Then finally, this is the structure which generally will look, and it is communicated with the AWS Transit Gateway. What do you mean by a transit gateway? That we are going to discuss now. The transit gateway is where transit gateway is a network transit hub that simplifies and centralizes the connectivity of your virtual private clouds. So as there are so many virtual private clouds, connecting them is very difficult. You can see in the diagram, understanding that particular diagram at the previous level is difficult. When we implemented the transmit hub, where we implemented AWS Transit Gateway, which is a network transit hub which simplifies the connections and centralizes the virtual private network. Hope you all understood well. By this I am closing this particular session. Please share, subscribe and like this particular video. Thank you one and all.